the quotient of restitution being E. Just we'll calculate velocity of the disk and velocity of the particle. So overall diagram is of like this. So this is the okay, there is a particle, it is approaching. No. So there's a particle which will be moving with a so this is the theta. Show some, instead of particle, no, show some like this. It'll be easy for you to write equation. So it is approaching with a velocity v. So this I'll call m1. I'm changing symbol. There's a radius r. No, okay, no, get into the question. It'll come and collide. So when it collides, what conditions will arise? So
So
first
the
thing,
masses are same, right?
no, disk of mass m, small ball of mass m. Masses are given same. Huh? I'll check it. Yeah, let it be here. Masses are small ball of mass m moving on a ground collides with the quotient of restitution being E. Yeah, masses are same. Huh? No. This small disk will come in contact with the condition. How the impulse should act, line of impact. I think the only best thing is what happened. We have to search for line of impact. No, along the line of impact, the impulse will be acting. So keeping that in mind, we can predict the in what direction, possible direction it can move. Okay, no. So just I'll try to make a guess of this one. What possible can happen for this after collision? So shall we just before collision? Shall we resolve this velocity? So here it is having velocity. So one component of velocity will be v cos theta. With that it will approach u1 parallel. I'll put it. So other component will be u1 perpendicular. So what is u1 parallel? U1 parallel is v cos theta. U1 perpendicular is v sin theta. And this is a test. How the impulse? The impulse will act in this direction. What is the possible direction in which it can move now? Anybody can solve once you reach here. We should apply conservation of linear momentum along line of impact. So same diagram. Let me take this. I'm giving diagrams in exam. You can't draw so many diagrams. You should imagine. I'm making clear. Just to make you understand, I'm drawing so many diagrams. In exam, there's no necessity to draw so many diagrams. You should straight away assume the things and work out. After collision, what do you expect the velocities of the colliding objects? That u1 perpendicular will remain same. u1 perpendicular will remain same. So this should be line of impact, common normal will come and collide. Common normal, common tangent will be this one, common normal. v1 perpendicular, this will be v1 parallel, and this will be v2 parallel. Why there's no v2 perpendicular? Because the impulse is acting only along line of impact, and initially this is a test. And finally, this what happens here. Okay, now get into the thing. What is u1 perpendicular? u1 perpendicular should be v sine theta. u1 parallel should be equal to u1 perpendicular v sine theta. u2 u1 parallel should be equal to v cos theta. And this should be equal to v1 perpendicular should be equal to u1 perpendicular, because now the impulse is acting along line of impact, and perpendicular component of the colliding objects which are directed, or the velocities, component of velocities which are directed perpendicular to line of impact will not change. So v1 perpendicular should be equal to u1 perpendicular. Any equation can we write? I should apply conservation of momentum along line of impact. Then applying that to anything directed towards right, I'll take it positive. So therefore m1 u1 parallel should be equal to m2, say, minus m1 v1 parallel plus m2 v2. Or this is only v2, will write it. Masses are equal, m1 equal to m2. So therefore this will be u1 parallel minus v1 parallel plus v2. Quotient of restitution formula, E should be equal to v2 minus of v1 parallel by u1 parallel. This is equal to E u1 parallel. u1 parallel is how much? V cos theta. v2, this unknown thing, keep it v1 parallel. Solving 1 and 2 will get v1 parallel and v2 parallel. Okay, fine, this one. So what is the speed of the ball? Speed of the ball will be v1 should be equal to v1 parallel square, v1 perpendicular square, and v2 will be this much. The velocity of the disk after collision, you'll get the answer. Later on, I'll update the answer. I have to check it somewhere. It's okay. I'll give that one. 37. This will be C. 38. This will be D. Yeah. 39. It will be B. Check answers later on. Calculate. Now let's come for velocity of disk after collision, speed of the ball after collision. So I think that's what V2 and V1 they're asking. Then afterwards, the velocity of approach of the system ball plus disk along line of impact. What is the velocity of approach? Only V cos theta, no? Because the disk is at rest. Very small things really troubles a lot for students. What is the thing? This is before collision, during collision, this is after collision. You should have these three diagrams. Two-dimensional collision only things are required, because during collision will help us a lot in predicting what will happen. Before collision will be there in the book, in the question paper. During collision only you have to draw a diagram in exam. Then you know that after collision they will move. Here only you show it, put an arrow something or something and show it, and write on. No need to other draw it. You have to save time like this. I'm telling this one. Everyone knows how to do problems. Saving time is very important. Before collision, question is there in the diagram. Leave it. During collision, draw the diagram. And after collision, here only you show that arrows. The final velocity can be like this. Here only you have to, this will be moving like this. Okay, then write down the equation. And what is the best thing? Line of impact is what going to help you a lot in two-dimensional collision.